Mixtures and solutions. Concept 3. Saturation. The essential question is, what occurs when a solution is saturated? In order to answer the question, first we need to make a solution. Here we have plain water. Now we need something that will dissolve in the water to make the solution. I'm going to use salt because salt is soluble in water. Soluble means that it is able to dissolve. I'm going to add 1 scoop of salt at a time. When I add the scoop of salt to the water, I then need to mix it up. In this vial, I'm able to shake it to mix it. So I'm going to mix the water and salt together. As I'm doing that, the salt is dissolving into the water and it is making it more concentrated. You can see that most of the salt has dissolved into the water. Now I'm going to add more salt. I can see that there's still room for the salt to dissolve into the water, so I'm going to add more salt. And again, I'm going to mix it so that the salt will dissolve in the water. As I add this salt, again, the concentration is still increasing. I can continue to add salt to this water, and the concentration will continue to increase until I reach this point. I made this one earlier. I have added so much salt to this water that it can't dissolve anymore. The concentration increased with each scoop. It got saltier and saltier and saltier. Now, no more salt can dissolve. You can see it on the bottom of the vial. It's sitting there because it cannot dissolve into the water anymore. The concentration has increased all the way to the point where this is now saturated. When it is saturated, the concentration can't increase anymore, and the salt can't dissolve anymore, so it sits on the bottom. When you first add a solid material to water, the concentration level is low, or what we might call dilute. As you add more of the material, the concentration level gets higher. As you continue to add more of the material, concentration reaches a level where it can no longer increase. It has reached its limit. It can't get any more concentrated. This is called saturated. When a solution is saturated, concentration can no longer increase. Sometimes when you have a saturated solution, you need to find out exactly how much salt was used to saturate that solution. In order to do that, we need to separate the extra salt that did not dissolve from the rest of the solution. We can use a paper filter to separate it because the big pieces of salt that did not dissolve are big enough to be caught by the paper filter. So I'm going to take a cup, place it under the paper filter. I'm going to mix this up a little bit so that it pours nicely. And I'm going to pour this mixture through the paper filter. The paper filter is catching the pieces of salt that did not dissolve. And the only material coming through the paper filter is now the perfectly saturated solution that has reached its concentration level. Now I can take my perfectly saturated solution and use a balance to weigh it. I'm going to put my solution on one side and I'm going to use gram pieces on the other. 20 grams, 30 grams, 40 grams, 45 grams, 50 grams, 55 grams, 56 grams, 57 grams, 58 grams, 59 grams, and now it's balanced. So I know that my perfectly saturated solution weighs 59 grams. Now that we know how much the perfectly saturated solution weighs, we need to figure out how much salt was able to dissolve before it was saturated. We know one important piece of information, which is that 50 milliliters of water weighs 50 grams. Since the solution started with 50 milliliters of water, this is a very important piece of information. We can take the weight of the saturated solution and subtract the weight of the water. So the weight of our saturated solution was 59 grams. We can subtract the weight of the water, which was 50 grams, and that will give us our answer. 9 grams of salt was able to dissolve into the solution before it became perfectly saturated. For this concept, you need to know what occurs when a solution is saturated.